Hello everyone, my name is Mildred. I am your instructor for this course. Today we are going to look at how to create a database. We're going to look at how to create tables within a database and the different data types and constraints that we can enforce on the columns or the column definition when creating a table. Before we create a database, there are certain things we need to know and understand. And these have different impacts on the performance of our database or on the type of data that we're going to be storing on a database. So the first thing we are going to look at is the storage engine. Now, there are two types of storage engines in MySQL. We have those that are transactional and those that are non-transactional. And when we talk about transactional, if you go to your week first content, is when we have things like operations that all succeed together or all fail together and roll back. And we're going to look at that towards the end of this part when we create our own database and we try to insert related data into multiple tables using transactions. So we have transactional and non-transactional storage engine, and InnoDB, written like this, is the default storage engine for MySQL, and I think it was made default from versions 5.5 and above, but prior to that we had a different one, MySQL, which was a default storage engine. Now, the storage engine, what it does, it has certain features that does different things. For InnoDB, it provides the ACID compliance transaction features along with foreign key support. It supports like multi-version concurrency control, things like crash recovery, rollback operations. We can also use it to offer things like table locking method, which means only one user can alter the table at a time and stuff like that. If we're using MySQL, it's a higher speed storage and retrieval engine than the InnoDB, but it doesn't support transactions and also for foreign keys. When you know what you want to do with your data and the kind of application you are building, you will look at the different features of the different storage engines, their advantages, their disadvantages, and see what works for you. But you want to see what your SQL server supports, what storage engines you already have. You use the command show engines like this, and it's going to list all of the engines that you have. So these are the engines we have. It has all of the definition. Let me show full text so we can look at it. So we have all of the different engines, and it tells us the ones that are transactional and non-transactional. So we have InnoDB here, which is a default, support transaction, row level locking, foreign keys, and encryption for tables. And this is always what we want for the type of application that we are going to create in this course. We also have MySQL, which is non-transactional engine. It has better performance, but small data footprint. It does not support transaction also. There. The other different types that you use for different types of depending on the type of data that you want to store. So we use these different engines when we are creating tables for us to specify what engine we want. If we don't specify, the default is going to be InnoDB for the tables. The other thing we need to know before we start creating database is character set. Now, when we talk about character set, is a set of symbols and encodings. Let's give an example for us to understand why we say the character set is a set of symbols and encodings. Let's say we have the letter A, or let's say we have the letter X, and we have Y. We say something like X is equal to 0 and Y is equal to 1. X and Y are the characters, 0 and 1 are their encodings. Let's just use this as an example to understand what we call character set. X is 0, so when we call X, we know that the value is 0. Y is 1. When we call y, we know the value is 1. The encoding for x is 0. The encoding for y is 1. Together, we call it character set. We have collation, written collation like this. And the collation is a set of rules that we use to compare the characters in the character set. Now, why is this even useful and why does it make sense? We have several languages in the world, different spellings, different letters, diacritical marks. When you want to spell something in German, the way the letter O is written is based on the pronunciation, the accents, and all sorts of letters. So we have thousands of them. If we want to build for multilingual support or multilingual applications, we have to take note of the character set and the collation. Different character sets exist, different collation exists. When you know the application you are building and what kind of characters you want to support and what type of collation you want to support, then you choose your character set and the collation within the character sets that you support. Now, what is a collation? We say it is a set of rules for comparing characters in a character set. So how does this make sense? Let's say we want to check, for instance, let's go back to our x and y value. X is equal to 0 and y is equal to 1. We want to check if x and y are equal. The rule that we have is check if x and y is equal. That rule that we have is called the collation. We have several sets of rules and call all of them together collation. So we can choose to store strings in a variety of character sets and collation. So you can research the available character sets and the collations and see what is best for your use case when you are creating database and tables for your applications. But now let's take a look at the available collation that we have from our character set. If we want to support multilingual application, the best one that we always use is the UTF-8, written UTF-8 like this. And for those of you coming from course 1, you know we always use UTF-8 as a character set because of its multilingual support. It supports a lot of characters and symbols from majority of the languages that we have. So how do we use this? First of all, we want to see what character set and collation we have. And this is always available in the information schema. Every time you have your MySQL installed, you always have an information schema there. And the information schema has information about your character set, your collation. You want to check it, you use a select statement like this. Let's say select collation name, character set. So I think it should be character set name from information schema dot collation. And we just want to see the character set that we have for UTF-8. We are going to be using UTF-8 MB4 character set. So let's see the collations it has. Then we'll start creating our database with that character set and the collation that we'll select. So we want to select the collation name, the character set from information schema table, from information schema database, and the collation table. And let's use a where clause to just filter it one time, where let's say the character set where the name is equal to, we said we want to use UTF-8 MB4, and we want to look at the collation name, because collations always have a prefix of the character set name. So we want to use the like operator in MySQL. I don't know if we've looked at that or your pre-recorded video has this like operator. but we want to see where it contains things like, so say like we'll use percent first. So where it starts with UTF-8, MB4, and Unicode. So we want to select the collection name and the character set name, which are columns in the information schema database table called collations. We want to just check for where the character set name is UTF-8 MB4 and the collection name starts with UTF-8 MB4 Unicode TI or contains or Unicode or contains that. And when we run this, we should be able to see all of the collation name and the character set name. So we don't have anything displayed here. We wanted collation name, character set name from information schema.collations, and we want it where the character set name is equal to UTF-8 MB4 and the collation name is equal to this. Now we don't have anything displayed. Let's try again and use maybe an order by clause, because now there are more than one, and if we use an order by clause, we might be able to, let's see, order by collation name, right? Let's see if this will work. No, we still don't have that. So let's look at the information schema, and we have the collations table. In the collations table, we have character set name and we have collation name. They're all there. So let's come here. So we want to select collation name and character set name from information schema dot collations. Let's remove the collation condition, and we have them here. So we want to see where the character or the collection name is UTF-8 MB4. So we can get or where the character set name is UTF-8 MB4, so we can get all of the collections. So there are many ways you can do this. So let's say where character set name UTF-8 MB4 and go. So we're seeing all of the different collections for UTF-8 MB4 for this character set. There are 33 of them that we have, and then you can read up the different collections. You can use general CI, Unicode CI. I'm going to be using Unicode CI. Depending on your application, you can use Roman CI, Turkish CI, Swedish CI. So different languages, the type of data, your region, you take into consideration what exactly you are building the model for. Okay, so this is how you check for the character set and the different collation names that exist within the character set, so that you can start creating your bases and the tables within a database, specifying the character set you want to use and the collation you want to use for the database. Now let's get a hypothetical scenario. Let's say, for instance, that we want to have information about a school. And in a school, we have things like administrative staff, we have teachers, we have students. The teachers are assigned to subjects and classes. The students belong to a class. The students belong to different age groups. They have different sex and gender identities. A lot of information about a school like that. So let's use this hypothetical scenario to say we want to create a database where we want to store information about this hypothetical school. To create a database in MySQL, and note that before now we have been using existing database. Now we're going to start to create our database, put records in our database, plan a database, and see how we can create tables that keep to the ACID properties. And I'm using ACID properties a lot, and I don't know if I've told you what it means, but when you say database keeps to the ACID properties, we have A for atomicity, which means that the entire transactions within the database will take place at once or does not happen at all. So if you watch your pre-recorded videos last week about transactions, you would have seen how that was done, but we are going to look at it live next week or the week after. The C in the ACID stands for consistency, which means that the database must be consistent before and after a transaction. So you don't want to have a database where, because you updated one record, if you check the student table, the age of the student is 18, you want to check the general users table, the age is 20. There's no consistency, so it's not keeping to the ACID property. Isolation also, we have things like multiple transactions should occur independently without interference. And then we have durability, which means that the changes of any successful transaction will occur even if the system fails. So once you have a database that keeps to the ACID property, then you have a very good database structure, and your data is going to be useful across different research and different use cases that you want to use the data for. Okay, so now that we understand what it is, we can now start performing different operations. To create a database, we use the statement create database, written like this. And then a name for the database. You can give your database any name you want. If I say create database school, I am going to be creating a database called school. This is a basic way and a bad habit in creating databases. Create database school. It will work fine. A database will be created. But in the event I have a database called school already, then I'll have error messages being shown. I don't have any character set or collation defined for this database, so it will use the defaults that I already have. But we want to deliberately specify these things. So we're going to learn good habits from the beginning. When I want to create a database, I want to use the condition create database if not exist. This way, if the database does not exist, I'm not going to have any error about the database already exists, you can't create it. But if the database exists, if the database does not exist, it will create it. If it exists, I won't get an error. The database already exists, so it won't create a new one. So I'll say create database if not exist, and then the name of the database called school. When I do this, I want to specify the character set. So I'll say character set, and the character set I want is UTF-8, MB4. Let me put it in lowercase, sorry. And then I want the collation, which will specify using collate, and I want it to be UTF. It's always prefixed with the name of the character set. UTF-8, MB4, and underscore, Unicode, underscore, CI. This is the one we want to use. And once you do this, and we click on go, you should see that we have a new database called school created here. So we have the school database created. Now we have the database, it is empty. For us to start storing our information, we need to have tables. There are other things we can have later on that helps with different transactions, like stored procedures, functions, views, but we'll start with the tables now. And then next week and the week after, we're going to look at how we create views. And then in part 3, we're going to look at stored procedures and functions. Now we have created a database. We want to see all the database that we have on our server. We use show databases like this. And this will list all the databases that we have here. We have our school database that we just created. When we have a database, we need to store information in it. Information is stored in tables. The tables store data in rows and columns. Each row represents information. So let's say that in our database, we want to create a table where we store staff information, for instance. To create a table, first of all, there are concepts we need to understand. And we want to understand the data types in MySQL for tables. We want to understand the different constraints that we can enforce on the column definitions before we can actually use the create table command. When we define the columns, we already understand what data types and what constraints each of the column will have. Any question before I go further? Okay, so no question, and we're going to look at the different constraints in MySQL. When we define a table column, and we're going to look at that shortly, if you specify not null like this, it means that that column, any row of data you insert, that particular column must have a value in it. And there's no value to throw an error, it will reject the entire row of information. So when you have your front end, your form, and you have all those fields that are required, if it is not filled, it throws an error that the value must be filled in. And the database, the back end, the not null column enforces that that information must be entered. When we say unique, for instance, you have your driver's license number. Only you have it. So let's say that the transport department has a database of all the people with driver's license. Your number is unique. That column where your driver's license number resides is going to have a unique constraint, which ensures that all the values in that row are different from each other. So there will be no conflict of identifying somebody and then two people have the same number and you don't know which is which. Everything is unique. We have another constraint we call primary key, like this. And primary key just combines uniqueness and not null in one definition. It enforces that that particular column is not null, so the value must be entered. It must also be unique, so it must not be duplicated across all the rows. Even if you have 1 million record, everything in it must be unique. Every 1 million must be uniquely identified. So once it's a primary key, it is unique, and then each of the row of the table is uniquely identified by the primary key also. Then we have something we call foreign key, written foreign key like this. And when you have a foreign key, it just keeps the link between tables. So it prevents the actions that will destroy any link between tables. When there's a foreign key, so foreign key is like you have a parent and you have all the child tables that inherit values from the parent. If you enforce a foreign key constraint, it means that you have things like on delete. If you want it to cascade, if you delete the parent, the whole children goes, or you want to restrict, and or on update, if you update a parent, you want all the values in the children to be updated, things like that. So let's say, for instance, a father has a last name. The father changes his last name and he wants all the children to have the same last name. All we need to do when there's a foreign key constraint enforced on all the children is that when the father changes the last name, it tails down all the children automatically. So it keeps the link, it doesn't break it. But in the event where there's no foreign key, then the link is broken. The father's last name is totally different, and then we don't know who the children belong to. So that's just a real life example for foreign key. We're going to look at how to use all of these constraints and how to create tables that have that link between themselves using foreign key. We also have check. And this check we use to ensure that the value in the column satisfies a condition. Let's say we have a registration form, for instance, that collects information. We want people to register on the site to be like 15 years and above. And then at the back end, the database, we want to make sure we have that layer of validation also. And so we want to put on that particular column a check constraint that checks that that value entered is not less than 15. So that's what we use the check constraint to enforce. So we have a default constraint that we use to set a default value if no value is specified at all. So these are the constraints that we'll use most commonly, that we're even going to use all the time when we create database with table information. So you can actually watch your pre-recorded videos, research more about constraints and have deeper understanding. And now that you understand or you know the constraints that exist, we'll look at the different data types that we have so that we can create a table and use all of these data types and constraints in our table definition. Any question? Okay, so we have data type called char, and then you specify a size in the pair of parentheses. This is a fixed length string. If you have the data type of char for a column definition, you can actually specify letters or numbers or special characters. But the size parameter that we have here in this pair of parentheses specify the length in characters, and that length can be from 0 to 255, I think. Yeah, from 0 to 255. So it's fixed length. If you say, for instance, password must be only 8 characters, char 8. So it's fixed length of information you want in that column. If you want variable length, you just want to specify a maximum size that can be there, we use something we call varchar, like this. And when you specify things like maybe 200, it can be below 200, any number below 200, but never above 200. So if you want to put like the data type for a name, for instance, we all have different names, different lengths of characters. So you might want to put like a maximum size here, variable length character, so that it can accommodate any length of name that the person has. Okay, so char is fixed, varchar is variable. We have the same thing with binary. Binary is like char also. We have binary written like this, and then you put the size here. The same thing like char, but the difference is it stores binary byte. I think for this one the default will always be 1. Yeah, and then we have something we call binary also, which is also like varchar, but also stores binary byte strings. So, just like varchar, what you specify here is the maximum it can be. It can be below the maximum or equal to it, but not more than it. When we have binary large objects, we have something we call blob, tiny blob, and we can specify, let's say, tiny blob like this. And then we specify the max length is usually 255 bytes. I think everything is 255 characters, 255 bytes, things like that. So we have tiny blob for binary large objects. We have tiny text that holds string of text with a length of 255 characters. So if, for instance, I have a field, for those of you coming from front end, I'm not using an input field, and I'm using a text area. And you know that people will type more things in the text area than in an input field. I want to store that data, I might decide to use a text. Text will hold a string with a maximum length of 65,000, I think 535 bytes. And so at that point, if you ask somebody or you have an examination portal, you want them to write an essay, to leave a note or write a paragraph, you want to use the data type called text for that column. So we have tiny text too. If you don't want a lot of text, but it's still larger than a normal input field, we call it tiny text. So I want you to research the other string data types that we have that store string. We have the ones that store number. We have medium text, medium blob, long text, long blob, enum. Enum is one thing that you need to know, enum and set. Let me just touch on that. When you have enum is like you have predefined values that they have to choose from. I think you can list up to 65,535 values in an enum list. So what you do is to have enum, and here you put the value. Let's say you just want it to be yes and no value to be selected from. So you define that column as enum yes no, and then on the front end it will be a select or drop down list of yes no or an option of yes no, exactly like the enum that you have defined. Okay, but the enum objects can only have one value, choosing from the list of possible values. When you want to have more values, you want to use sets instead of enum like this, and the data type, and then you list everything there. So you can list up to I think 64 values in a set. Yeah, for enum you can list up to 535 values, and in a set you can list only up to 64 values. So for enum you can only select one choice. Set, you can select 0 or more values from the list of all the possible values that have been specified. So by the time you know what these data types are, and you define your columns, and you know exactly what you are going to be information that you are going to be collecting from the front end and storing in that database, then you know how to define the table columns. We have numeric types that are like byte, bit, bit. We have tiny int. We have int that we use a lot. When you have int, you can specify the number, or you can just leave it as int. We have medium int, tiny int. We have bool, boolean. We have integer. We have float. We have double. Okay. When we have float, floating point number. When we have things like double, it's like a normal size floating point number, and the number of digits you want will now be specified in size. We have date time types where you can put date. You can have date time. You can also have timestamp, and you can have something like time and then year. And I want you to research all the different data types, but we are going to be using most of the string data types, the numeric data type int most of the time, the date time when we want to have timestamp automatically inserted, especially when we have a column created at and created by and all of that. So now that we know the constraints and the data type, it is time for us to create a table. So I need you to read deeper and research deeper about table data types and constraints. To create a table, you have to select the database you want to use. My database is already selected, school. I'm written here database school. So for you are going to write use school if you're using MySQL Workbench to know exactly where you want to create a table in. Okay, I've already selected school, so I don't need to write that. To create a table, we use create table and then specify the table name, and in a pair of parentheses we are going to list as a comma separated list all of the column definition. Column, let's say column 1, all the data types and constraints, column 2, data types and constraints, column 3, until the last column, all as a comma separated list to the end. Now again, this is a lazy way of creating a table. We want to create a table if not exist. So we say create table if not exist, and we give the table a name. Let's say we want to create a table for the staff of the school. So we have created a table if not exist staff. Now the column definition. I want to have an ID column that will auto increment, which means that there will be like a serial number, but it's going to be unique for as many number of staff that is going to be inserted into the table. So even if it's going to be 10 million staff, it's going to be 1 to 10 million, something like that. So I'll say ID, because we want the ID to be numeric. The data type is going to come next, which is int that we just discussed. The constraints that we have, we say auto increment. I don't know if I discussed the auto increment constraint. It's just that automatically increments the number. So if I insert the first record, it's going to be 1. The second one will automatically increment 2. The third one 3. Fourth one 4. So auto increment the ID number. And then let's say we just want this to be the primary key once and for all. So because it's going to be unique and not null, so the number is unique to each person. Then we want a second column that we want. Let's say staff ID. Now the staff ID, let's say we want to enforce that it is a 10 character staff ID. It's alphanumeric, but it's 10. So we'll say SHA-10, and then we want to say every staff must have a staff ID, so we enforce a constraint called not null. We want to have this staff has a name. Let's say we want a different one for the first name. And we know that names will have different lengths. Different people have different names. We want to use the data type called varchar. Let's put the maximum length of 255. And then we want to say everybody's name must be entered. We'll enforce not null. Another thing we can enforce on the staff ID is uniqueness. Maybe we want the staff ID to be unique. We can say not null. Let's say we want it to be unique also. There's another constraint we can add. Now, enforcing not null unique is the same thing as saying just you have primary key here. So if you don't want an ID column that auto increments, you might just want a staff ID here that is not null unique and there's no ID. There is another way we can actually put the constraints at the end, just define a table and the data types. At the end, we name the constraints and put them. I'm doing it this way because in the pre-recorded videos, I use that method. So you can have different ways of doing the same thing. So let's say we have the middle name and we want to also assume that we have people with very long names, so the same maximum of 255 characters. And we'll say this one will allow null values, but we'll say in the event that somebody does not have a middle name, just insert null as the value. So we'll say default null. You can have any default value. Like for instance, you can say default, give it a default name, no name as default. Or it be something that is numeric, you want to put default, default date, default figure, things like that. So let's say you are building an examination portal where there's they create assessment and you want to put a default grade. So if the person creating the assessment does not put the total grade, you can say that the default be 100%. But if the person say, okay, this assessment is going to be 500%, then they can specify in the absence of that 100%. So things like that. And you specify default where you want to make sure that things keep happening even when the value is not inserted and you still want to use it for data analysis. So last name, varchar 255, and let's say the not allow null here. We want everybody to have a first name and a last name at least. And let's say we have the date of birth, and then we want this to be of type date, and we'll say not null also. We want everybody to have date of birth. Now take note that once you have defined the last column, there must be no comma at the end. It is a comma separated list until the last one should have no comma. Once this is done, you have created a table called staff. The staff has an ID column, a staff ID column, a first name, a last name, a middle name, a date of birth column. We can click on go and it creates this. When it creates, you have a success. Now we can see that we have a new table called staff. When I click on staff, I have all my columns here for me to start inserting records. But we are not going to insert record in this lesson because I want to use the inserts when we look at next week's planning model and creating all of the tables with the foreign keys. And then we want to insert via transactions and see how that keeps to all of the asset properties that we want. So anybody has question? Okay, in the absence of question, this is where this lesson ends.